The next thing to look at is the hypothesis. This is your prediction or your guess of what the experiment will do. Remember, it's okay to be wrong. That's really important. You don't need to get the hypothesis right. In reality, a lot of the time, we will be wrong because remember, if you think back, the purpose of an experiment is to find the answer to something we don't know or confirm an answer. So sometimes we might say the hypothesis is to confirm something. Most of the time, we're investigating, we're exploring something because we don't know what's going to happen. So it's a very short, clear statement that describes what you think will happen. Remember, don't use first person. It's not I think. And it needs to also clearly outline the dependent and independent variables in that statement. We're going to test the hypothesis and talk about it later. If it's wrong, or we would say it's refuted, we don't say it's wrong, that's okay. If it's supported, not if it's correct, if it's supported, again, that's great, but it doesn't matter either way. So usually we state the hypothesis most of the time in an if-then statement. So for example, we would say something like, as the, or if the something increases, decreases, then the something will increase, decrease by, and then we talk about what amount, what relationship, etc. Sometimes this format doesn't work, but most of the time, I would say 9 times out of 10, your practical report can use this format. So if we go back to our plant, if the volume of water increases, then the plant height will increase by a linear amount, or increase up to a maximum value, something like that. Remember, we predict, we do not justify. So often I'll see people write a hypothesis, and then the next sentence in the same hypothesis section, they'll say, this is because, no, don't justify it. We don't know the reason. You don't need to justify why you've come up with that theory. You just predict it. Independent and dependent variables must be clearly mentioned in the hypothesis. And ideally, include more detail than just saying it'll increase or decrease. That's a very sort of lower level, like middle school sort of era method. Often they're taught just to say it will increase or decrease. But for us, that's a little bit too basic. I would rather see some sort of relationship. So will it be linear? Will it increase by a linear amount? You may also say it'll increase at a directly proportional rate, which is just the same as linear. You might say it increases up to a maximum value before stabilizing. You might say it decreases exponentially. Doesn't matter, but aim to do it that little bit more than just saying increase, decrease. That's a bit vague. If you say it increases and it does increase, great. But how do you know how good your hypothesis was? Did it increase in the relationship you expected? If you don't talk about a relationship, you can't talk about that. Let's look at an example. If the number of hours spent doing homework increases, then, so we've got if then the grade of students will increase proportionally. Great hypothesis. Very clear we're talking about hours doing homework and student grades as our variables. If the mass of the falling object increases, the final velocity impact will increase exponentially up to a maximum value. Clearly got mass, final velocity, variables, relationship, exponentially to a maximum value. And lastly, if the distance the object falls from increases, then the resulting force on impact will decrease exponentially. Again, distance, force, exponentially relationship. Good hypothesis.